In this video, we're going to talk about the law of large numbers. So what is the law of large numbers? Well, let's say if you perform an experiment multiple times, the observed average of the results will approach the true average or the theoretical average as you increase the number of trials. So let's use an example to explain this concept. Let's say if you have a coin. If you flip a coin, there's only two possibilities. You either get heads or you get tails. The probability of getting heads when you flip a coin, it's 1 out of 2 because there's two possibilities, only one outcome is a favorable outcome. So it's 1 out of 2 or 0.5, which means there's a 50% chance that you'll get heads. Now, let's say if you flip 10 coins. Now keep in mind, this is the theoretical probability of getting heads. But let's say if you flip 10 coins, will you get 5 heads? Because that's 50% of 10. You may get 5 heads or you may not. You might get 4 heads and 6 tails. Thus, your observed probability in this case is 4 out of 10 or 40%. Now, let's increase the number of coins. So let's say if we flip it 50 times. Now, we may not get 25 heads. Instead, we might get, let's say, 26 heads and 24 tails. I forgot to put the H. But if we get 26 heads and 24 tails after, let's say, throwing 50 coins in the air, the probability in this case will be 26 out of 50. We got 26 successful events out of 50 coin tosses. So the probability now is 0.52. So let's increase it. Let's say if we toss 100 coins in the air, we might get 49 heads and 51 tails. In this case, it's going to be 49 over 100 or 0.49. Now let's say if we did it 1,000 times, if we threw 1,000 coins in the air. In this case, we might get 497 heads and maybe 503 tails. So the probability will be 497 divided by 1,000. And so that's going to be 0.497. So notice that this number is very close to 0.5. So the more coins that you toss in the air, the probability will get closer and closer to 0.5. And so as the number of trials increases, the observed probability approaches the theoretical probability. And that's the basic idea behind the law of large numbers. Now let's use another example to illustrate this concept. Let's say you wish to measure the average weight of everyone in a town. Let's say there's 20,000 people living in town XYZ. Now you don't want to measure the weight of all the individuals living in this town because that's going to be a lot of work. But let's say if you take a sample. Let's say if you take a sample of 5 individuals. The average weight may be 160 pounds. Let's say if you take 10 individuals and you measure their weight. The average weight might be 154 or something. Now let's say if you measure the weight of 50 individuals, that number is going to change. It might be 163. And let's say if you measure the weight of 100, that might be 161. But eventually, as your sample size increases, these values will converge. And let's say if you measure 200 individuals, it might be 162. Or let's say if you measure the weight of 500, it might be 161.5. And so notice the value we're getting closer to. we can see that the average weight of the individuals in this town is somewhere around 161, 162. If we measure 1,000 individuals, which will take a lot of work, we might find that the average is 161.8. So we could say that the average weight of people in this town is somewhere between 161 and 162, because as n became very large, we see that the average is converging to this value. If we were to select just one individual, we might get an extreme value. We may get someone who is overweight, maybe like 230 pounds, or we may get someone who's underweight, which may be like 10 pounds. So you might get an extreme value if you just select one person, but as the number of individuals that you select in your sample increases, then the average will approximate the true average of the entire population. And so that's another example of how the law of large numbers can be used to estimate parameters of the population used in samples.